feel free to jump in to the teams for our challenge questions throughout the lesson. Actually, we're more towards the end of the lesson, but that's okay. But yeah, so I'm taking notes. So get them out, and then we'll get started.
Hey Martin, do you mind logging into the Teams because my computer is freaking out and won't let me sign in.
Sixth grade. Alright.
Wait, you got your computer out?
Yeah.
This makes no sense.
Everybody's got it. Yeah, actually, that looks like another, not this lesson.
Curtis.
Yeah. Yes, I see there's more. Excellent. Jordan. Thank you.
Wow, good stuff, man. You're so smart. You're so smart. Oh. Plug your computer first,
You
Nick.
can.
Yeah, I got it. You know what? He's gonna charge it. That comp is gonna be on six.
Alright, I've checked all notes. Did I miss anybody? It's going twice.
Bro, reach up around the table
Alright, our dad joke for today. I can't trust my air mattress. It is always lying behind my back.
Ah.
Smart.
Who do I get to sue for this?
Who do I get to?
A what? Anything bad? I mean, technically yes, but I mean, they're camping themes jokes, so.
Well, the laptop.
We go in towards camping.
Oh, yeah.
Nobody else pulled it up?
But
Mine's
if I said that I can't trust my
I asked somebody else to.
that's the thing that I see every single
You're
day.
taking forever singing about
But
Martin.
you can't trust your air mattress, but you only use it every once in a while. I don't know.
His
I guess.
computer is off, Jordan.
I'm not going to try to
Yours is
throw
on.
that other relationship. Just gonna leave that alone. Hi, Tracy.
Team. You go to see the team page. And then one
I
of
closed
the.
on my laptop. Wait.
Okay. Let me real quick send
It's gonna be your ass.
What is your gun sound like? Bro, what's wrong with my laptop, bro?
Mr. Vander, how you feel about the Super Bowl last night?
I didn't watch it.
You did.
That's real. Thank
You
you.
mean so that you mean so serious?
I don't know.
I didn't watch it.
My Eagles mid.
What?
I don't care.
My Eagles are champions.
Thank you.
Okay, buddy.
Yes.
Okay.
Yes. I love this energy.
I was going for the Eagles.
People dissing on me.
It's so
because I
nice
hate
to
sports.
actually not be involved about
Exactly.
something. So.
Like I
Wait,
didn't
you're
watch
going-
it, and I
you're
didn't
going
want
for Eagles.
to. I wanted to go to sleep.
That's surreal.
Y'all chose to stay up. During the
Were you going
halftime,
for
I was
Eagles?
taking a shower. I heard the music. All I heard was, they not like us. That's all I heard over and over again. I was like, okay,
You people in Philly,
that's great.
White power, we can Cooper Eugene pick six. Yeah.
Okay.
I
have really indifferent. Oh yeah.
I still didn't use the bathroom.
Great corner.
Tesco's.
What's that?
Mint.
That's a big ass man.
That's a big man.
That's a big mint.
You-
I've met big
You're
Oh yeah, no. I only take mine like that tiny. Those big ones,
No?
too much, bro. Too much for me.
It's not. It's
Did
not.
you even try?
Yeah. Yeah, that's it.
I'm not quit. That's it. Yeah.
Sit on the floor.
Y'all love the halftime show?
I'm talking to him.
I wish they put more SZA.
Down.
I wish they did more SZA.
Yeah.
It was too many of his
Hey,
new
don't talk about
songs.
my wife like that.
I say it was too many of his new songs. Like they
She
needed
looked
to do like
pretty.
some.
She looked
Yeah, I wish
nice.
there was more singers.
She looked
They didn't use her
beautiful.
a
She
whole
looked
lot.
gorgeous.
They did it.
Because one of her Super Bowl was
She's a
They have Serena
she's a person.
Yeah, like what's
That was funny.
Dudes kind of suck.
So we have two people playing games.
I'm not gonna lie, I was about to play Google Snake. I'm not gonna
Playing games here.
I'm not gonna lie, I was about to play Google Snake. I was about to get on Monkey Mark. No, I'm not gonna do that.
Okay.
That was fine.
So yeah, I heard that there were tennis players at the halftime show.
Serena
Crip
Williams.
walking.
She was
towns
dancing.
were they showcasing?
Crip walking.
Crip
She
walking?
was dancing on her ex.
Because you know Serena and Drake, they used to date, so she was like getting back at him because you know the Drake and
The song was about
Because the
him.
song was about Drake. I
And
heard
she's-
about that. Yeah.
Wait, I didn't know.
Okay.
They said they-
Yes, yes.
Yes.
Okay, that makes sense. I don't know. Anyway, let's get to physics.
And Drake and SZA used to
That's just a
date.
huge Super
I'm
Bowl
with
commercial.
you.
Drake and SZA used to date.
Yeah. SZA.
Halftime SZA.
She was with
I don't know these names.
Kendrick, who performed.
None of it matters because Drake broke.
You know, I need to not know these names too.
Oh,
Let me get holy like Mr. Maple. I'm sick of it.
Drake all time type of thing.
Let me get like Mr. Maple.
It's 1:32. Alright guys, a couple of announcements real quick before we get started. Number one, as you can see with the homework, for the work from home schedule, whatever, we do have school on Friday, okay? It was originally a weather day, but you know, we had some storms, and so we are taking that as an official school day. So Friday, this Friday, is a regular day of school. In fact, that's what our test is.
Burn it down, burn it down.
Let's not talk about that.
I was thinking of something else. Don't worry about
Should
it.
we have I believe
Let it down, let it down.
Are my grades?
We can't even burn the school down.
17 is
Rip.
Yes. I always thought about that. I was gonna burn up whatever's inside.
what?
We have to slowly fill it with the gasoline.
Okay, yeah. So
Unless you wanna like.
we do have school on Friday, so make sure to show up. All
No,
right.
thank you. I prefer not.
Second, I did post the deets
I didn't
on
post
our third quarter project, which is a spinning top project.
I was in the newspaper for
Feel
that.
free to check that out
I was
and
exactly in the newspaper.
read over those things and see what you want to get started on doing.
Maybe just last. Maybe that's what I know.
Project
They were like.
Oh yeah, it was for the grad batch, but the only senior I have is Tracy, and she's not even in the room. So there you go. All right, so let's get rolling here. Last class we talked in great detail about how objects, specifically charged objects, will move through electric fields and through magnetic fields, but we didn't really mash them together until today. Also remember that a big thing about the electric field is that the force from the field on the particle, it really doesn't matter where the particle is moving, as long as it's in the field, then there's going to be a constant force in the same direction, which we learned about. But the magnetic force field, or the magnetic field force, yeah, there you go. So that one is going to change how big it is, as well as its direction, based on where the particle is moving with respect to the magnetic field direction, which we'll kind of have a little review here in just a minute. So, with that said, let's say that we have a magnetic field in a region of space, like so.
Like so.
Where is this field pointing?
Inside?
Wait.
Out towards you.
That's
Yes.
my bad.
Point is out, X
Yeah.
is in.
X.
Yes. Alright, and then, but we also have to have an electric field as well. Let's say that the electric field strength, let's say points up in the particular region. So there's both an electric field and a magnetic field in the same space. Okay? So now we're gonna have, let's just keep it easy. Let's say it's a proton, okay? And the proton is moving, let's see,
Upward.
let's say it's going to the left
Dang it.
at a certain speed v, okay? Now, it is possible, if things are properly oriented, that it can go through the gauntlet, if you will, of both the electric and the magnetic field space and not be deflected at all. That it goes straight on through, as if, those fields aren't gonna bother me. I'm alright.
Show God.
Okay,
It's a chill
so
proton.
let's take a look and see exactly how this works. Where is the electric field force pointing?
Upward.
It points up. Are you sure? You should be, because you're right. Because remember, the electric field force, we don't use the right-hand rule. It's the simpler one, right? I mean, you flash it up.
Going to the point
Ah,
I fail.
Or, as we say in camping, you know, oh, it's just a little trail spice, that's all. I mean, granted, I might actually trust dirt more than what we find on our floors here. So. I don't know. Because, I mean, dirt's natural, right? It won't hurt you if you add a little bit to your diet.
A spoonful
But
of
then you
dirt.
say, well, so is arsenic. We shouldn't eat that either. There are lots of things that we should not ingest because they're poisonous. Alright, so remember from last class, or maybe a couple classes ago, that the electric field is going to be pointing in the same direction as the force on a positive charge, right? Yeah. So if we got a proton, that's a positive charge. The E field points up, which means that our force, the electric force, has to point up as well. Okay? Now, where's the magnetic field force pointing? That one we will have to use our right-hand rule magic.
Is it upward?
I can barely see anything, if I'm being quite honest with you.
So remember, we point with V, bend with B, and then our thumb points with F.
Up.
F is in frame, as in force. So V, the B points out of the page, right? So a V, B, force points up.
Okay, great.
Okay.
I
So
can
far, so
barely
good.
see what that arrow was.
Now, so if both of our forces point up, will that ensure that the particle will go straight across and not be deflected?
I don't think so.
No,
They'd be
no. And
imbalanced.
now technically, if they're small enough, we might be able to cancel out the force of gravity, but we're actually going to ignore the force of gravity in this case, because we know that the electric and the magnetic fields are going to be way stronger than the gravitational field strength. Okay, so if these two forces are pointing up, then there's no downward forces that we can think of, because we're ignoring gravity, which means that it will not go in a straight line. But where will it go if this is true? It's gonna curl up. Yeah. Okay. So, but we don't want that. We want this to happen. So, here's my question. What do you think we can change about the situation to make it work like we want?
Negative.
What things can we change this situation so that the forces will be opposite instead of going in the same direction? What you think?
So when I stop.
What if we flip the electric?
Sure you did. Oh, sorry.
Oh, wait, what if we like...
Let's do it.
Well,
still go up.
there's only certain things that we can change. First up, you might want to change the sign of the charge. That
First thing
Negative
maybe,
one.
I mean,
it's possible, right?
negative one.
Or we could change the
Negative
directions of, well,
On the
there's
electron
actually
charge.
3 things that we can
Electron.
change. We could change the velocity direction, we could change the electric field direction,
Electric field.
or we could change the magnetic field direction.
Magnetic field direction.
Any one of these could possibly, maybe,
You are
affect or make it happen like this. What do you want to see first?
Magnetic field direction.
Magnetic.
Magnetic field? Okay, so what shall we do? Where should we point it now?
Down.
That way.
I'm gonna say
Down.
downwards.
Okay, so let's say we say the magnetic field points down.
And it's still open. Jordan, don't make me hurt you. Your wife is
So
always-
the E field points up, the magnetic field points down. All right, let's see. So where's our electric field force? First.
Shut up. You're engaged.
It's still up, right? Because we didn't change the E field, so the FE still points up.
Uh-huh.
Okay, so we really changed our B field. Let's find out where our force points now. All right, so point with V, point with V, bend with B, and our thumb points with the force. Where's the force point?
Out of the page.
Out. V, V, force. Yeah, you're right. So the force points out.
Getting married and don't even know the Lord.
Do those cancel out?
No.
No,
Probably so.
no.
We have
Try again.
Oh.
That direction.
We'd have to
Wait, don't
point
erase it.
inwards,
Wait, the other way?
inside, right?
Wait, no.
Well, you gotta go that way.
Go like
That way. That way.
point.
No.
Wait.
What is going that way?
The
Easy for you to say.
magnetic
Wait, it has to go
magnetic charge.
So the B field?
Yeah. Yes.
So the B field, you
I
say
thought
you
the
want
B field
to
still
point that
goes-
way.
No, people wants to go up.
No,
No,
it goes up.
Yeah.
What? I thought it was
Yes.
on the up.
I want to say up. Because point, bend, inside. Wait, no.
All right. So if our B field points up, where's our force point?
Are you gaslighting me right now?
It goes.
No.
Inside. It would go inside. Wait.
B, B, force is in.
We need
Will that?
we need
We gotta get a force out.
Will that force cancel that force? No.
No.
Okay.
So I need to send V in that direction.
Huh?
Why can't you just send V in that direction?
Oh yeah, into
Oh,
the page.
okay.
Into the
Like,
page.
Well,
yeah, make
let's
the
try
P
it.
go
Now-
that direction.
Should we reset our B field
No.
to what it was originally?
No.
Keep it like that?
Yes. I don't know.
No, why can't I put it inside?
All right.
Come
hold
on, just think
hold
a little bit, Jordan, before you speak.
Let's think about it before we just jump into our next step. Okay.
Think a
So
little bit.
if my force electric
I'm so lost.
points
I
up,
love monkey mind.
okay, then my force magnetic has to point down. Okay. So we could actually use our right-hand rule to kind of give us the middle part as well, right? Because we know that we will point with V, and in the end, our thumb will point where the force is. And then once we find out where those two things are, then our fingers will naturally bend towards where the B field needs to be. Okay? So
The force.
So if we keep our same V, if we're changing our B around, okay, if we keep V, but our force needs to point where? Down. So as I keep my thumb out, I turn it down. So V, my thumb points down, and then therefore my fingers will point in the direction of the magnetic field into the board. You did? Well, then you should speak up because you were right.
He's not kidding.
All right.
I feel like I was right.
So
Jordan, you was dead
it
wrong.
was actually opposite
Were you saying that the whole time?
of what we had before, right? Because
Yes.
before we had the dots where our B field pointed out and then our force pointed up. So if we think way back to the beginning, if we're just flipping around the force, we just needed to flip around the magnetic field. Because that's really what we have now.
Stop. I'm so smart, y'all. I think he did it.
All right, so again, V, B, B, our force points down. There we go. Now we're talking. All right, so we're cooking now. We're cooking.
Oh yeah.
All right, so now that we know that, all right, well, this is where things are going to have to be to satisfy this requirement here, okay? I wonder if we could get an expression for the speed of the object in this situation.
No, you're not.
Okay? Now, we know that it's going straight across, so we already know that these two forces, are they going to be balanced or unbalanced? Balanced, yeah, because Newton's first law says that as long as our forces are balanced, the object will continue moving in a constant velocity, right?
Yeah, yes.
Yeah. So the fields are going to be in such a way that the electric force is going to balance out or cancel out the magnetic force. So if we know that they are equal to each other, or they balance out, then we can set them equal to each other. Okay?
Sounds about right.
So then we're going to come up or derive an expression for the velocity here, or the speed. So using this FQ equation, solving for F, that's just going to be Q times E. So, and again, E is the E field. And that's, remember, we also had our force acting on a charge, QVB sine theta. And remember, the angle is going to be the angle between the velocity and the magnetic field vector, which is, so if the B field points into the board, the V is pointing to the left, that is a right angle, okay? So the sine of 90 is 1, so it's just QVB. Okay, so plug that in, QVB, and we're going to solve for V. Notice that, oh look, the Q's cancel. How very interesting. And then solving for V gives you a very simple E divided by V. Isn't that neat? Now, this is in our books. However, if you notice, there's no little symbol next to this equation, which means that it's not in this book. Which means we're going to need to have to derive it. But we just did. That was easy. That's even easier than our centripetal force equation that we talked about. Remember, as we pass a charged particle through a magnetic field, and then it went in a circle, right? And so we have our R equals mv over qv. So this is even easier to get than that is. Okay? Cool. Thanks.
Congratulations.
Not done yet, but
Oh, you're not done.
no. Well, I'm done with this particular little subtopic.
Yeah.
Subtopic.
Yeah.
We gotta learn about the
Now,
V.
what's the main-
No, the FB.
Oh yeah. So speaking of this equation, this kind of jumps us into our next little subtopic, which we'll just spend
I'm measly 30 minutes on
In
this
the dark.
project.
no. So sometimes we may have to use this whole charge to mass ratio thing. Okay, charge to mass ratio, as in if we had a magnetic chamber and we were shooting charged things into it, and we saw the past, the circles that it made and all that fun stuff. So we would need to know either the charge or the mass of a particle in order to identify the other part. Okay, but if we don't, if we're just looking at raw data here, it might be better for us to have a charge to mass ratio of different things. So really, we're just going to have to rearrange this equation, solve for Q over M, okay? Charge to mass. So in a ratio, you guys know that the first thing goes on top of the fraction, the second thing goes on the bottom, okay? Like a, just like when we graph and we say y versus x, the y is the first thing, it goes on the y-axis, and then the x part, whatever comes second, goes on the horizontal axis. So the order matters. The same thing with the ratio. So if we're looking for a charge to mass ratio, we're just going to rearrange this equation, solve for Q over M, which ends up, so basically we're going to multiply both sides by Q over M, which is the reciprocal of this, to get it over here, and we're going to divide both sides by R, so we get M, no, just kidding, the M's gone, V divided by RV. So based on how fast the particles are going and the magnetic field, then we can get the charge to mass ratio based on the size of the radius of curvature as we see those paths in the little chamber that we have. Charge to mass ratio.
Wait, in what instance would we use that?
Whenever they ask for charge to mass ratio. Like,
Yes.
I don't know, maybe in questions 13 through 15?
Sorry. I don't even know what those are.
Or I guess just 13, because that's the only one of the set that I picked.
Oh, thank you, man.
So yeah, so number 13.
We love you, man.
You didn't just pick 13.
Oh,
Oh.
never mind. I take it back.
You take it back.
Of this little block of problems, just 13. I mean, there's more because there's other subtopics.
He thought his only point was 13.
Why are we using this word subtopics?
Because it rings true with Dana. And
Uh,
I want to connect with my students.
and I'm scared. Why is there a
Don't be
sub?
scared.
It's one topic.
I don't bite. Often.
See?
Hey, yo there, bro.
I'm just kidding. I don't
What are
bite.
you talking about?
That would be weird. Why would you say a thing like that?
That would cross the
Oh,
line.
bro, Dan, why would you say it like that?
Especially since we're filming this thing.
Oh, wait.
Lauren, cut it out.
not
Cut it out.
bite
He's
his
serious.
ears.
It's fine.
Uh-huh.
Martin
Yes.
does not edit.
Martin goes.
Wrong.
Do not edit.
Every
Do not edit.
every mistake
Every class is raw footage.
Mr. Maynard makes in class.
Oh my
he
God.
saves
Teacher
it
bites
for
his students.
Sure.
What do they call it?
nefarious
Clickbait.
use.
Yes. He's gonna have a clickbait
Well, I hope
title.
not. Huh?
He's gonna put a clickbait title.
Teacher
I'm
bites
gonna-
his students.
Put a fake what?
We're gonna put
A
it. we're gonna-
clickbait title.
A clickbait title.
So it's
Oh,
not true.
clickbait, got it.
Yeah.
Got
There
you.
you go.
Got you. I thought
Took
we
you a
were
while there,
gonna
buddy.
get definitions.
Now y'all don't start things, alright? Alright.
You
So
like to
then we're gonna
televise
wrap it up.
right now.
So
Let them all record it.
so let's take a look. So we've talked about a couple of different things, but we're gonna sit on this last topic for the last 15 to 20 minutes, okay? And then we'll be good. All right. So we know that there is if there is a wire and a current is flowing through the wire, and the wire creates its own magnetic field. Okay. We've also learned that because of that, if that wire is in a magnetic field, not of its own making, then there will be a force acting on the wire. But what if we have two wires? Okay. They will exert forces on each other. Let's take a look. So, two long
You're not important.
parallel
You can.
wires that have currents flowing through them. Let's say both of the currents, let's say this is I1, this is I2. Let's say that they both flow up in the plane of the page. All right? So I want to know what's happening with the forces on these wires, because I1 is going to cause a field in the space of I2. And I2 is going to cause a field in the space of I1. So they're going to interact with each other. The fields are going to exert forces. Here's the real question. Where do those forces point? They can either attract or repel or neither, and both of them are going in the same direction. Options. Okay, well, let's find out.
I hate options.
Oh.
So, first though, I need to find out where is the field strength acting at the location of the wire. So let's take a look at I1 first. Okay, so I1, and we're going to use our first right-hand rule. So our thumb points with the current, and our fingers will curl in the direction in a circle around the wire. So look at I1 and see where is its field that it's making in the position over here to the right of it. So where's our B field pointing? To the right, in this spot, based on the I1.
This
Inside?
Wait, what's the
Into
first?
Well, our eye points up, so our thumb should point up, right?
Right.
Yeah.
And then our fingers will curl in a circle, going
Into the
around the wire like that.
Counterclockwise.
Counterclockwise, okay.
Wait.
Counterclockwise as seen from above. Yeah, you are correct. Okay, so if we're looking at where is it pointing to the right of our wire, where is it pointing?
Into
If
the
it's
paper.
going
Into
into the board. Here you
Yeah.
go. You got it. Yeah.
So it's a dot. No, it's
Uh-huh.
an X. Is it an X? Is it an X?
Good. So our B field points in.
Bring that
I'm
back.
learning.
Now, same process, but now let's take a look at I2. I2 points up, and it's going to make its own field in the region to the left of it, which is where we're going to look here at the first wire. So where does that B field point?
Out of the page.
So our thumb points up,
That's out the page.
and it goes again in a circle around the wire like that. So when it's to the left of the wire, where is the B field
Out the
pointing?
page.
Out of the page.
Got
it.
Why is it different?
Yeah.
Because
Put your hand pointing in
Little-
the direction.
into, out. That's
Right,
the
right,
field.
right, right, left, right.
Okay.
Okay.
Wait,
So, yes.
I'm still gonna fill this unit test.
I'm kind of confused on like why this one was going in and why that one, why the other one was going out. Like I know that like the dot and X thing.
My favorite
Na, na, na,
toy.
na.
Okay.
That's not fair.
So, our current points up, right?
Stop.
So which means that my
Stop existing.
fingers will curl in a direction, going around in a circle
Okay, you don't gotta.
of the magnetic field. So if we're on this side, our field points away from us. If we're on this side, our field points towards us.
I got you.
Wow, can you keep spinning that? That's beautiful.
I would, but my arm would get tired.
I can hold it.
Don't let her hold it.
I mean, you
We
can.
have better things to do now. Later.
You're on recording then.
Oh, of course he is. But now she's out of frame, so.
Please put that down. Why
Alright,
did you give the most
so,
pages up in class?
Step one is good. We've identified where our fields are pointing. Now we have to use the second right-hand rule to find out where the force is pointing. All right? So let's take a look at our force acting on I1. So again, we're going to point with I, bend with B, and our thumb points with the force.
Alright, so wait, say it again.
Point with I, bend with B, and our thumb points with the force.
So I going this way, right?
No, I points up.
Who
Wait,
thought
for
of
I1?
this?
I1.
So like this.
So,
Yep.
Alright.
Point
And
with
bend
I.
with
question.
Bend with B.
I'll choose bathroom.
Wait, which way is? I
just
can't
kidding, I
see
can't
B.
leave.
that
Where's
way?
B pointing?
So to the
to the left.
To the
That's
left.
to the left.
I can't see. So.
Doink.
Alright, so our I points up, right? And our B field points out towards us.
How do you know that?
Because
Dot.
of the dot.
Oh,
It's a
that means it's
dot.
going out?
Yeah.
Okay.
So that means,
So that means I flipped it
it's
this way, right?
way.
So-
So it's going left.
I,
One this way.
B,
It's going this way.
C.
force points left.
ABC.
I'm sorry, right?
Oh, I see
My
what's
bad.
going on, guys.
See, according to my perspective, I'm left, but that's your right. So I gotta fix
Yes.
my
Okay.
thinking.
I
Yeah.
was like,
So again, I, B, because B points out, and then our thumb points right. All right. Now, same thing. Where is the force acting on wire number 2?
Left. To the left.
Okay.
I'm not mistaken.
Point with I, bend with B, and our thumb points with the force. I,
B.
It goes
B,
Goes to the left.
Force.
to the left.
To left.
To the left, to the left.
Watch me still fail this test.
It's not
You
all
got
about
it.
Ah.
right hand.
Exactly.
So, what's the nature of this force?
They attract each other.
It's an attractive.
Ah. Oh.
I know.
Mm.
I played to the camera. All right, so check it out though, all right? So if we've got two wires and their currents are pointing in the same direction, it doesn't matter if they're both up or down or left or right, as long as they're pointing in the same direction, okay? So if the currents are in the same direction, then our force is attractive. Woo! Yes. Just in time for Valentine's Day. Yes. Now, I wonder, what if they're opposite?
If it goes up, it points, and if it goes that way, it points out.
Better.
I imagine they repel.
You're so right. You know what?
So,
Oh wait, no, maybe the.
now if I change the direction,
I think they're gonna go in the same direction.
That's it. He got rid of all his stuff.
if I change the direction of I2, okay, so the B field from this one doesn't change, okay? But now I have to re-evaluate this B field. So now my I2 points down, my fingers curl in a direction, and in the direction to the left, the B field points in.
The brain cells.
Yes, they were. We're
Why'd
changing.
you chew it, you weirdo?
Where's my green marker?
I say it repels each other.
They repel?
I think so.
I hope they repel.
I use my mind.
It makes sense. Oh, never mind.
All right. So now let's find out where our forces point.
Okay.
So on I1, I, B, force.
Yeah, that makes sense.
Oh, I am cooking. Wait.
I2, I, B, force.
Wait, no.
Hold on.
Huh?
Wait a minute.
So how'd you know how to
Wait,
put
I
your
won. Wouldn't
how'd you know how to
force
put?
go out of the page so it would be a dot
I'm saying, how did you know
on the
how to?
I2?
Like, where he was supposed to put it?
No.
So I2, current points down. Based on our B field, the points in.
It go down.
So I, B field points in, thumb points right.
Why,
How
like?
do we know that it goes in?
Oh, I ate down.
Because according to I1, current points up, and our fingers curl
Oh,
into
okay.
the board on the right
Wait a
side.
minute, alright?
Yes.
So when
I
you
used
went
my
up, right?
wrong
You
hand.
started with your hand facing that way, right? So you went like that,
But he
right?
corrects himself.
But then you go down, right? And your hand facing the other way.
Down, and then you're gonna put your fingers into
Well,
the page.
I'm going to rotate it wherever I need to, so that
When you get
when I
different
bend my fingers,
not
they will bend
twist your
towards B.
arm?
When you get different hand.
Can you twist
Huh?
your arm?
Dude, homie.
Jordan, twist
Can you
your arm.
Alright,
bend
You
your
play
fingers the other
basketball.
way?
I'm confused.
our B points into our board, right?
Yes.
Okay, so if I start with my hand up like this, I've got to turn it so that my hand points like that, or my palm does, so that when I bend my fingers, they bend towards the B.
Oh.
Okay.
So how you know?
If I'm like this,
Are you saying, oh, just
okay, I gotta
No,
rotate my
like that.
hand around to
It has to
where
face into the board.
point,
Right.
yeah,
So how?
So
would
how
you
you
do
know
the
it?
other
How you know it goes
one?
into the board?
X in the
based
dot.
on the first right hand rule.
I know the dot says
Point,
outside the
point.
board. How you know?
I1 points up,
In.
Point and then turn.
so our thumb points up and our fingers curl into our board when it's on the right hand side.
Oh.
We did that already.
Oh.
We just went over
that
this.
shit makes so much
That's
sense,
why we
bro.
have the wheel.
I might be a genius for real.
And he gets a better score than me. I'm so confused right now. Like I've never been so confused.
Okay, so in
I
the
just
end
got
though,
that
because we gotta move on, alright? So notice that when they're opposite, what kind of force is that?
Repel.
A repulsive force. A repulsive force like you.
Oh,
Dang.
that's so mean.
So if the currents are opposite, then our force is repulsive. Either way, here's our new equation, and the only one that we have left for us for today. So this is actually a force per unit length. As in, if we don't know how long the wire is, we have a force for every meter of length if we could measure it. This is force per length, okay? And in our equation sheet, it says that this is going to be equal to, oh look, it's a constant, mu naught, that's the permeability of free space, which again is just a constant, which we can look up in our booklet here, times I1 times I2 divided by 2 pi r, where r is going to be the distance from wire to wire.
Too simple.
Yeah.
Why did my brother do that?
Okay. So, knowing that, let's take a look at our first round question.
You have to scratch my
Oh yes.
It's me, that's you.
All right, I'm gonna share.
We have a single challenge question.
Yeah, because he said that we're gonna have him at the end of the class.
We're doing our little sub.
If it involves independent, I'll pay like God.
And he failed us.
Are you still in the team?
I'm in the team because he didn't even try.
This is a comparison question.
Why does it extend one way and half the other way?
Because that's what they
Well,
chose.
it's B. It's B. It's B.
Bless you.
It's B.
That's what I was gonna say.
It's B.
Yep.
It's B.
Am I?
I'm
Yes, I should check
Go.
the phone hub.
I'm a fucking legend.
Girl.
I'm an ancient Mesopotamian.
You're ancient. Yeah, what?
I'm an ancient Mesopotamian. Come on. I'm a godlike. I'm a one.
Oh, it loaded, bro.
I'm a messy.
You were watching. Did you not watch it load?
Dumbass, put it behind them.
Who couldn't even open Teams on their laptop? Oh, because you could have done this
Y'all
yourself.
be nice.
Oh, bro, he's so mean to me.
Alright, looks like we got a couple of B's.
Type job. That's cool. That's cool.
Oh look, there's more B's.
I'm trying to work on my anger management.
I'm pretty sure that's right.
No.
I
Mr. Maynard.
I believe so.
Chill out. I put so much effort into thinking about that.
Is it your final answer?
Yes.
Yes, I just.
You're my final answer. You mean my 13th reason why.
Can I what?
Maybe 11.
What?
Can I reveal the answer choices?
Why not?
Zoom in.
Why not 8?
11.
Why not so?
There was so much shit before him. It was never his fault. If anything, it was the textbook.
I'm a misfit. That means I don't fit. I don't fit. I just bought a coupe.
His music taste is a little questionable.
Lord forgive me. I know I'm a sin tonight. Probably did.
I tried.
Friends
I'm not sure if that works when I put it into the focus. But it's basically a fourth, half,
There's one
or.
Spanish song I know. Spanish.
It's canzone. No. That's French.
Alright, I'm gonna call it done, guys. I'm gonna call it done. 3, 2,
People are saying it.
On that floor we had.
1.
That's French.
Yeah.
I don't think it's
Alright, we got A's, B's. Let's take a look.
Can I still text
So-
you if I'm in a crisis?
I don't know.
So we got two long parallel wires,
I'm
P
getting close,
and
but
Q,
I'll-
are a distance D apart. So D would be the R in this equation. A magnetic force per unit length F. So they combine it, so they just say the F over L is just F. Okay, so they make it easy for us. So the distance is increased to 2D, and the current in Q is decreased to 1/2 I. What is the new magnetic force per length acting on these charges? Okay, so we gotta look and see, well, what's changing? Okay, what's changing? So the R is changing. The R is now twice as big. So I've got a extra factor of 2 down on the bottom. Now notice that it's not like R squared, or there's no other powers here. So it's really just an extra 2 on the bottom. Okay. Now it also says that the I from the Q, so a current is going to be half as much as it was before. Okay? Resist the temptation to combine the 2 in front of the pi and this 2.
No. I already said that.
Because we are trying to find what is my new force per length, which means that I need to write the new one in terms of the old one, okay? Now, the old one was this in black. So mu naught I1, I2 over 2 pi r. So because the 2 pi is in the original, we gotta keep it in the new one as well. Okay, I can't combine that 2 with that 2. I gotta keep them separated, like the offspring dogs, okay? Yeah, so that means that we've got our mu naught I1, I2 over 2 pi r, because that was my original, right? And then we've got 1/2 divided by 2, which does not cancel out. Those 2's do not cancel out. That's a complex fraction. That gives us 1/4. So, and since that is really f, then f over 4, I believe that is B. Is the
I'm the
correct
greatest guy,
answer.
bro. Like, what was I do without
Okay,
you?
not
You
too
did
much.
not even
Yes.
solve it.
I said B
The
first.
B's have it.
I said B first.
All right, we've got Quantum taking first place,
That is so real.
Look at tears falling on the floor.
followed by Up and Adams taking
You know I
second.
answered it by myself, right?
Tears falling on the floor.
And Mutant Maniacs rounding out that third place point.
Your whole face.
Have I contributed to the team?
All right.
What was I do without you, bro?
Next challenge question.
Alright,
I was scary, yo.
another one.
Jordan is done. She's tired.
Y'all got a headache.
Mr. Maynard, you got time off?
Kind
I don't
of
think the teacher's allowed to give us
situation.
I see it.
You know? It's a true study.
Okay.
I actually just saw that change, but it happened after done, so it didn't
You was
count.
playing.
Hey,
Martin thought he was smart. Haha, stupid. I've been waiting for that one for a while.
Oh,
I think it's low key C. Like, I won't lie.
I'm not gonna lie. I didn't read any of this, and I have no help for
I
it.
think it's low key C. Like, I'm not gonna lie to y'all. I think it's low key C.
What do y'all want to put?
Mr. Maynard looking at me like I'm either smart or dumb. I can't tell.
No.
Because I'm telling you, it's not D.
Might be
That-
C because
D
they
is
both
first of
cancel
all.
out, but
D is completely
A
wrong.
looks-
A is completely wrong. And it's between B and C. But I think it's low key C.
What do you think, Jordan?
Jordan, what? Got any ideas?
looks like we got B's, B's, and C's, and D's. Wow.
I had a casual fear that dog out his face.
Don't actually know. Here we go. I'm gonna call it done though. 3, 2, 1. Done. All right, let's find out. So,
Oh, you slid in
these
there.
forces between the wires, whether they would be attractive if they're pointing in the same direction or repulsive acting in opposite directions,
They said C.
would they be different forces if the currents weren't the same?
No.
That's a good question.
Yeah. Notice that this force per length is based on both of the currents. Just like, remember the force of gravity, right? We have two masses out in space. There's a force of attraction between them. And the force of attraction is based on both of the masses. And of course our distance here. But these forces made an interaction-action pair. Newton's third law. They have to be equal and opposite. Do these also have to be equal and opposite?
No, wait.
Yes, they do. Yes, because this wire's field makes that force, and this wire's field makes that force. They are intertwined.
Exactly.
Okay, these forces are the same number, so it is either A or D. The forces have to be the same, regardless.
I told you to look at me like I was a dumb.
No, you said that you weren't sure.
Yeah, but fine.
Told you, he's looking at me like I
So
was
it's
stupid.
either A or D. Now the real question is it 1F or 2?
I think it's
Okay.
one F.
Well, let's take a look. It says, let me
Oh my
erase
god, I
my
didn't even see the one app.
previous work here.
Oh, A, yeah, because it's on the
I didn't even see the one app. I was just guessing because I got.
Okay. So it says the current in X is halved. So 1/2 the first current, but double the second current.
Can I delete this comment?
That 1/2 and 2, they cancel. A is the correct answer.
God dang it.
Mr. Maynard, you can't do that. You can't put two, like, you can't put the two answers on separate sheets of paper. I thought that was part of the problem.
W got
You didn't know that went from B to C to D?
No, I was
Ideally,
confused.
ideally, it would be all on one paper. I apologize.
Free
That means
play?
everyone gets a point.
Free
Next time.
point.
You played yourself, bro.
No, I looked it out.
So A's haven't.
I was like,
Let's
it's
see,
too
looks
easy.
like
I knew it was
Maniacs
just me, bro. I knew it.
taking first place this time.
I even did the math, bro.
Aw.
Aw, imagine doing the math.
Oh,
Curtis.
and that's it.
Come on.
You
You
know what
said
that
C.
means? They get all 6 points.
Oh.
Hey.
There's an
Yeah.
opposite class.
I don't know how.
All right, last question,
I
guys. Last
did the
question.
math. I would get the answer.
And this will wrap it up.
I didn't even notice that.
That didn't just split it three.
Oh, it's alright.
Yeah,
That's.
You might actually need to calculate for this one.
I think 14 more fair.
I'm a fight for you.
I got it.
Ooh, actually, hold on. Not yet.
We went back to the
There's
other
one more
question.
thing before we hit that.
Can I lose my calculator, y'all? Don't think just
Now,
because
let's go back
you
to the.
will straight up.
Remember how there's a force acting on a wire. So F bill is equal to sine theta, or F equals bill sine theta. Remember that if we had a magnetic field in a region of space, and we had a wire with a current acting at an angle, and the angle was in between the current and the B field. So we learned that if the wire were perpendicular to the B field, then the sine of 90 is 0, so we would have maximum force. And then as the angle increased, or rather decreased until we get to 0, now we have 0 force. Because the sine of 0 or the sine of 180, in both cases, is 0. So we have 0 force acting on a wire that has a current that's in a field if it is aligned with the field itself. Okay, so keep that in mind. Now, what if we had this? So we had our B field pointing up in a region of space, and instead of just a length of wire, let's say we have a loop. Like the loop. Yes. We actually have a decent gluten-free pizza option. It's expensive, but it's decent. Actually, we've just discovered Costco gluten-free, the cheese ones.
Yes.
Those are
I heard cheese. I'm hungry. What's happening?
the best. Anyway, so let's say that our current flows clockwise around the loop. So this way, and that way, and that way, and that way. So I want to know, is there any net force acting, what's going to happen with the loop of wire as it's in this magnetic field? All right, so more practice with our right-hand rules. Let's take a look at this top section first. Is there a force acting on it, and if so, where?
Gravity.
Well, let's ignore gravity. Let's just talk about the B field force.
Oh, yes. Oh.
Yeah.
Forces.
Points up.
Yeah, I think so. Yeah.
I, B,
Oh, outward. Okay.
force is out.
Wait a minute.
Force is out.
No, you can't.
Why am I hand going over here? Oh, I'm looking at that one. I'm looking at the I one, right?
Point
Yeah.
with B.
So,
Yeah. So.
Oh, wait.
Yeah.
Wrong
I,
hand.
point with B. Sorry, then with B.
Yeah,
then
come
force
on,
points
man.
out. What about this length?
Dana.
The side, right side.
Down. Wait, how does that make sense?
It goes down.
Would it cancel out?
and
Well, you're
It
on
goes
the right
left.
track.
It goes that way. It goes that way.
Nah, of course. Wait, since it's 180, would it be 0?
So it's a neutron.
Huh?
What?
Oh.
But Martin, what did you say?
Because it's the angle in total is 180. Wouldn't it just be 0 for the sign?
There is no force.
There's no force.
Because the wire is directly in line with our field lines. Exactly. So there is no force acting on that little branch of our circuit.
So then we can cancel the.
Got it. This side is also 0. Okay, there you go. All right, now, is that one 0 too?
No.
No. All right, so where does that point?
Into the page.
Just giggle.
So I, B,
Into the
4
page.
points in. There you go.
I'll make it plain.
Okay,
I
now,
call him Giggles, bro.
How
No,
do you
wait.
ever do 0 again?
hold on. Shh. So let's assume that this is a square, so all sides are equal length. Okay. So knowing that both of these have the same B field, and they have the same current, because there's only one path for the current to flow, and they all have the same L, and they're all at the same angle, then both of them have the same size force acting on them. It's just one goes out like this, and the other one goes out like that. So two forces that are opposing each other, wouldn't they cancel out?
Yes.
I imagine.
Yes. So if we have a net force of 0, we are in equilibrium.
Exactly.
Which means that the wire doesn't actually move through space. Or rather, so if it is at rest, it's going to stay at rest, right? Newton's first law. Or if it's moving through the field, it's going to keep on moving at its current speed and direction. But we know about rotation, don't we? Yes.
Apparently.
Imagine this loop of wire
Oh.
is attached to an axis, like so.
Why are we imagining this? I'm,
Do you want to learn or not?
no. Why would you ask me that?
Honesty's the
He's
best
lying.
policy.
Of course he wants to learn.
You're a nerd.
Alright, so let's say that this loop is an axis, as in, or is attached to an axis so that it can rotate. Okay? So, will it rotate? Will it be also in rotational equilibrium, or will there be a net torque acting on this?
I feel like it'll be in equilibrium now. It's only in 2D.
So, this wire gets a force out.
Uh-huh.
This wire gets a force in.
Oh, they cancel out.
So they cancel out force-wise, but do they cancel out torque-wise?
No.
Well,
If this is our page, and the top of our page wants to go out, and our bottom of our page wants to go in,
Yeah, we're like that. Going
it
like
would
this.
rotate. Yeah. So it would cause a net torque to occur, and this thing would spin.
okay.
Okay? This is essentially what a motor is, an electric motor. Okay? Think about it. We've got a loop of wire that's connected to a source of power. Okay? And we send the current through that wire. The wire is already in a magnetic field, and because the current is flowing through it now, there's a force acting on the field causing it to spin. And as it spins on this axis, perhaps this axis is attached to a wheel, like on your RC car.
Huh.
Oh.
This is the basics of a motor.
Wow. Can I make my own motor now?
Yeah. If you have a magnet and wire and a battery,
That should be our next lab.
you
Is
can.
this
No, it
mechanical
shouldn't be.
engineering?
Wow. What?
Is this mechanical engineering?
Make a motor.
So technically it would be more electrical, but there's definitely components of both. If you were to build your own RC car, yes, there would be parts of both. Good, good. All right, let's do our last challenge question now, which may or may not pertain to what we actually just talked about.
I thought you said that he was 300.
I don't know how old
All right,
I ain't married yet.
now you will
I mean,
actually
James.
have to calculate, but I challenge you to not use your calculator.
Dun,
Don't you actually want I'm gonna take that as a sigh
You
of
can do it.
relief.
He says,
Without a
of course
calculator.
not.
You can do it.
I'm not gonna lie, y'all. I'm already feeling this like C.
Bro, I almost just found the area of this
Is it B?
rectangle.
I might be E. Oh my god. It's between A or D. No, it's between A or D.
Yeah.
No, it could be. It's in between A, B, C. I don't think it's C.
You to put an answer in.
I don't want
Or solve it.
I'm my own person. We're our own. That's right, Elijah. You should stand up for yourself. Yes.
Wait a minute, bro. I wanted to last look for curious all I can ask. Push me to the front. I can't wait. Well,
Jeez. Hirsch. Hirsch, boy. Hirsch. You already touch your hair. How about, I know it's
Mr.
either
Manning, you're really drawing
A,
this really incorrectly. I'm not gonna lie. I think this is a really incorrect
it's either
drawing.
A, B, C,
Well,
or D now.
it's.
Now pick.
Hey, how'd you go to the
I mean, it's correct. It just has a little bit of extra
Look at his drawing.
stuff in it.
Look at his drawing.
Yeah, because I simplified it.
My mind just blanked. Just pick an answer.
Time jump.
Don't.
Oh.
Just do what everybody else said.
I did B. Everyone's saying D, and then they're changing it to C.
Yo, how'd you get to B?
Bro,
My
can you
mind
mind the
blank.
business that pays you?
I need the explanation.
No, you don't.
What's the explanation? Oh, she got the C. They had the C.
Alright,
Look
we
at
got
the time
lots of
we see.
answers. We got
Look at the
C's
time
and
that we
D's and B's.
I picked it before the question was shown.
Changing to C's. There's no A's. Alright, I gotta call it down now. 3.
I think I might actually know the calculator.
Grab me, bro. All I gotta say is
Yeah, Alright, here we go. So,
However, it is just be wrong for something else.
first thing that I did is I said, okay, well, obviously, these two parts of our wire will not have a force acting on them.
Right.
Okay, but this one will.
Yes.
Right.
Okay, so as I follow the current, I see that the current is flowing to the left. Okay, so that's why I drew it more simplified here. And because the currents are pointing in the opposite directions, it's a repulsive force. So I already know, based on the second part of our thing, that it's either C or D. Because it's away from the wire, repulsive force. Because the currents are pointing in opposite directions. Okay, now that I've canceled out half of my choices, I could definitely guess, and that would give us a better chance of getting it right. But we don't need to guess. We're going to actually calculate what the real answer is. Since we know the length of my wire, then I'm going to multiply this over here, so I get the actual force. Okay, and then we're going to plug and chug. So as I look up that number, that's actually 4 pi times the 10 to the 7th power, right? Yes. Okay. Times 2 currents. Okay. So I got 10 amps times 2.5 amps. Okay. Times the length of the wire. My length of the wire is 4 centimeters. Now, technically, that should be in meters. But I don't have to convert it, and here's why. As I fill in the rest of my information, 2 pi times the R distance is 1 centimeter. Okay. Notice that if these are in the same units, the units will cancel. So I don't have to put them in meters if they're going to cancel out. Just like when we did our collision problems and we had the conservation of momentum, it didn't matter if they were in grams or kilograms because the units would cancel out. Okay? But if we had the impulse type problem, then it would. Okay, so now I can not use my calculator because I don't need to. So the pi's cancel. Look at that. The 2 cancels with that 4, leaving just a 2. So it's all just 1 on our bottom here. And then 4 times 2.5 is 10. 10 times 10 is 100. Times 2 gives me 200. That's 200 times 10 to the negative 7th power. Notice that our units are all in micronewtons. Micronewtons. Okay. Even if I didn't catch that, the fact that I have a 2 in front of my number says, okay, if C and D were my options, I'm going to choose D. I'm done. I'm going to move on. Okay. I don't have to get it completely down. I mean, right now I will, because remember our mu means times 10 to the -6. The prefixes are in here, remember. Okay, so you don't have to know them by heart. So to write this, I'm going to have to move that decimal place one spot. It gives me 20 times 10 to the -6 newtons, or 20 micronewtons. C is the correct answer. Oh, I'm sorry.
Oh,
I'm sorry, my bad. D.
I told you. I was about to be so
D.
D. Wait, Tyler was onto something. He was onto something.
All right. My bad. See, that's why I need to get closer to my screen before I
You're
say
right.
it. That was a
Wait,
free.
why? I
Alright,
didn't
so
tell you to
D,
pick
D,
it.
D, D.
You guys see down, I was like,
Alright, Bella changed her answer. Darn it. All right.
Do your own
Next
thing.
up goes
Why do you
Bradley.
guys do my
Bradley
voice?
changed his.
Yeah,
Oh,
I
he
did.
changed it to all the luck. Alright, so next D. Next D.
No one picked D.
Oh.
Oh, we're close. We're the first person to answer C.
You're like baby smooth.
But the correct answer is
I
this.
want to write on
Well, it's closer than. Oh yeah. I can make the argument.
Oh,
he's
fuck
closer.
it. They see it.
Huh?
Sorry, Dan. That was
Hey, we put D in.
Alright, guys, we are officially done.
Go with your gut next time.
Feel free to take 5. If you did not get a review guide yet, make sure to pick one up today. If you raise your hand, my lovely TA will pass out the review guides for you. So if you don't have a review guide yet, please raise your hand, and Tracy will get you your review guide.
Goodbye.